Alright everyone, welcome back to the day 34 of our daily lead code challenge, and today we have got longest strictly increasing or strictly decreasing subarray. So let's understand the question. In the given question they will be providing us with an array nums, and we need to find the length of the longest subarray in this list nums, which is either strictly increasing or strictly decreasing. So what are strictly increasing and strictly decreasing arrays? Are arrays in which the values keep on increasing with each element passing. So an array like 1, 2, 3, 5, 8, 9, 11, all these values, an array having all these values will be a strictly increasing array, where all the values are keep on increasing. With each passing values, we'll see the previous value is a value bigger than that. So if we are starting at 1, there's no previous value. We come at 2, the previous value is 1, so the current value is greater than the previous value. Every time we move forward, we will find that the current value is greater than the previous value. So this is what a strictly increasing array is, and a strictly decreasing array is an array in which the values keep on decreasing, meaning they could look something like this. They need not be decreasing by a certain fixed value, but they have to be decreasing. That's what it means. Like the values should keep on decreasing as we go forward. So if you see in this case, we started with an 8, the next value will be lesser than that. So it's 7 now, and in the next value will be lesser than 7, 5. The next value will be lesser than 5, 3. The next value will be lesser than 3. We have a 1. The next value will be lesser than 1. It's minus 8. If this would have been 100 here, then our strictly decreasing array would be until this point, because from here on it starts increasing. So this is what a strictly decreasing or a strictly increasing array is. And what we need to find is, we need to find what they have provided us in the given array nums. We need to find the length of the longest such occurring array, which it could be either be strictly increasing or strictly decreasing. So let's try to take a look at the first example, which is 1, 4, 3, 3, 2. If you take a look, as we discussed in the strictly increasing array, the next value will always be greater than the value which we are currently at. So we are starting with 1, the next value should be greater than 1. Is that the case? It is. We reached at 4 and we see 4 is greater than 1. So far up till here it's a strictly increasing array, and the moment we come on the third element, we see it's a decrease. It should, if this would have been a value greater than 4, it could have been 5, we could have considered this entire part. But since this is a 3 right here, this means that the array kind of decreased here. It was increasing up to this point and then it kind of decreased. So our strictly increasing array as of now is just of length 2. Then we are at 2 again. The next value could either be less than that or more than that. If it's same, then there is no point checking because it's same. And then we come to 2 again. So 2 again got a decrease. So this is our kind, you can say this is kind of part of a strictly decreasing array, because the next value is less than the previous one. So here, one length here that we are seeing of a strictly decreasing array as 2, and one length we are seeing here as strictly increasing as 2. So that is why the answer is 2. In the case of 3 to 1, if you see, we started with the value 3. So the next value could either be increasing or decreasing. We saw that we started with 3, the next value was less than 3, so we went down, so we are still decreasing. Now if the next value is either again decreasing or increasing, we'll see. So the next value is 1, which is still less than 2, so we are still decreasing. So this is kind of what the graph would look like for values 3 to 1. You could basically kind of imagine all these values and kind of plot it on the graph on the y-axis. You can actually kind of visualize the answer. So if you see in this case, we kept on going down for a length of 3 on the x-axis, length of 3 on the x. If you plot all these values on the y-axis, you will see that the length that we see of the slope is basically what the length is. The length on the x-axis basically what the length of the subarray is. In this case, this is a strictly decreasing array of length 3. Let's try to do the same thing for this bigger array. We start with 1, so we are at 1 right now. Then we reach 2, which is greater than 1, we went up. Now we reach 3, which is greater than 2, we went up. We reached 4, which is greater than 3, we went up. We reached 5, which is greater than 4, we went up. Then we came to 4, which is less than 5, so we went down. Then we came to 3, less than 4, we came down again. Then 2 is less than 3, so we came down one more time, and then 1 is again less than 2, so we came down one more time. You could say that this line goes something like this. Starting from 1, keeps on increasing up till 5, and then from 4 onwards it starts decreasing and going back to the same value. So if you see, the graph looks something like this. Imagine this as a graph. and this is where the values are getting split up till 5. So this would be a length 5 which is constantly increasing, and then length 4 which is constantly decreasing. So in this case the answer will be 5 because that's the length of the longest increasing subarray. This would be our longest increasing subarray, this would be our longest decreasing subarray, but in this case they want us to know the length of the longest increasing or decreasing. It could be any one. So in this case we are going to return just the maximum, which is 5. Now this is how the question is working, like this is what they want us to find. Now let us try to see how we can kind of solve this algorithmically, which using a data structure called as stack. So this is where stack is going to come in, and let's try to understand how we can use stack to solve this problem. I'm going to take this bigger example again, 1 2 3 4 5 and 4 3 2 1. So we have 1 2 3 4 5 and then again 4 3 2 1. So with stack what we are going to do is we will first use the stack to find the length of the, like in this question we saw there are two answers. One is this part right here which is of length 5 which is strictly increasing, and this part right here of length 4 which is strictly decreasing. We have to return the longest. It could either be strictly increasing or decreasing, doesn't matter. Whichever array we get, or we get the array with the maximum length, we're going to return that. So what we're going to do is firstly we're going to find all the strictly increasing subarrays in this list. That will be step 1, and in the step 2 we'll find all the strictly decreasing subarrays. The concept will be same using the stack, but the kind of the logic will change slightly when we'll be finding the strictly increasing or the strictly decreasing. So in step 1 we're going to first start with finding subarrays which are strictly increasing in this case. So we are going to initially start with an empty stack, and we will start iterating from here. So the first element, when we reach the first element, we'll see that the stack is empty, so we have no option but to append this value in this stack. So now our stack, when we are at this index 0, we appended it back to our stack. Now since we are in search of the strictly increasing array, what we'll do is change our max length, like the length that we have so far. This is our resultant array at the moment, so we'll kind of set the length of the maximum like subarray that we found so far as 1, right? That would be step 1, and in the next iteration with the next value we have to kind of compare with the previous value in the stack that we just pushed in. So if we come here 2, we see that the previous value that we just pushed in is less than 2. It means we are kind of on a increasing streak. So what we'll do is, if that's the case, where the next value that we just encountered from the i+1 value, which the next value that we just encountered, and the stack is not empty, there are two cases. The stack should not be empty, and the value that we just encountered is greater than the stack -1, meaning the value we just pushed in the stack. If that's the case, what we'll do is we'll push this value to the stack. Now our stack looks like this, 1, 2, and then increase the length by 1. Initially we started with length 0. When we pushed the first element in the stack, we increased the length by 1. We had no other option because the stack was originally empty. We set the length to 1, and we moved forward to the next element. The next element was on an increasing streak. We saw that the last value that we just pushed in is smaller than the value which we currently encountered. So what we'll do is we add that to the stack, increase the length by 1. Now the length becomes 2. Now since we need to keep a track of the maximum length of the increasing subarray, whatever increasing subarray we find, we need to keep a track of the maximum element. So whenever we are kind of updating our length of the increasing subarrays we are finding, every time we do that, it's a good practice to keep a track with the maximum length as well. So far the maximum length that we got will be 2. Initially we will start with the max length of 0. The moment we pushed first element in it, we updated the max length now to 1. Now the moment we push 2 in it, the max length now gets updated to 2. So far we are good. Then we move to the third element. We see that we are at element 3 right now, and the last element that we just pushed was 2. 3 is greater than 2. We are still on an increasing streak. So what we'll do is we'll push 3 now to the stack. The stack looks something like this, and we'll have to increase our max length by 1 and then update it. So now the max length becomes 3. Great. Now the next element comes as 4. We again see 4 is greater than the last element that we just pushed. So our stack now looks something like this, 1 2 3 4. and we'll increase the max length by 1 and then update it with the maximum value. So now our max length so far is 4. Then again we reach 5, we see that the last value that we just pushed in 4 is less than 5, or you could say the value that we are currently at is greater than the last value that we just pushed in. So we push this back again to the stack, it becomes 1, 2, 3, 4, 5, and we update our max length to 5 now, and yeah, that's it, we move on. The moment, now if you see, we our increasing streak is ending now. The moment we reach the next element, which is 4, now this 4 is less than the value that we just pushed in, right? So you could say that our increasing streak, whatever we had so far, it doesn't matter the length, whatever we had so far has kind of ended. So whenever the streak ends, we'll have to start from scratch, meaning we'll again initialize an empty stack. Now we are at 4. So basically you could say that the same thing that we started with, now we have kind of basically add 1 back again. The situation which we were at when we encountered 1 is what the situation again will be when we encounter 4, because this kind of occurring streak of increasing elements has now decreased, completely gone. So now we are at 4, so we will again initialize an empty stack. Our max length so far will be unchanged, it will be 5. We'll initialize an empty stack and then append whatever value that we just encountered 4 in it, and then since we are starting from scratch, so we'll update our length of the current, like the length 1 value, back to 1. Now since this is, we will be starting with this, now this is again our starting phase, we update it back to 1, right, and then we'll move forward. Now we see that comes 3, then again we'll do the max operation also, it gets done. So the length is so far 1, if you take the max it will still be 5, so it remains unchanged. Now the next element that we encountered is 3. 3 is not greater than the element we just pushed, so again the same thing is going to happen. We're going to set the stack to empty, append 3 in it and set the length to 1. So our max length is still 5. Then same thing happens with 2, we set the stack to empty. Since we are doing this empty part because the values we are looking for was an increasing fashion, since these values are decreasing in order, since we are initializing the array to empty, so that in the hopes that if a value comes, kind of greater value comes forward, we don't have to deal with all these behind values. So that is why whenever we encounter a lesser value, we'll have to set the value as empty stack, push this value back again, set the max length to 1, set not the max length but the length that we are currently working with as to 1, in hopes that a greater value comes in, and then we'll push that and increase that 1 that we just saw in these cases. But that's not the case, however, because it's still decreasing. So again same thing is going to happen with 1 as well. You're going to empty the stack and then append 1 to it and set our length 1 to 1. But with each time you're setting length 1 to 1, our max won't be unchanged, it will still be 5. So this is 5 in the case we are looking for all strictly increasing values. All strictly increasing values is what we get. So far this is the first operation we did for finding the subarrays which are in an increasing fashion. So if you see, we saw that 5 is the maximum that we got, and all these are decreasing. If there would have been further more greater arrays, like greater values after 1, we could have included that, but since they are not, so we just gonna have 5 as of now. Now since this was the case where we are looking for strictly increasing arrays, now we're gonna have to do the same thing for strictly decreasing arrays. So far we did the same thing, so far what we did was for the strictly increasing arrays. Now we need to do the same operation. You'll see we're gonna have the same operation, the logic is gonna change. We were comparing the value that we just pushed, the value that we just pushed in the stack should be less than the value that we just encountered for strictly increasing. In the strictly decreasing, it will be flip side, meaning the value that we just pushed in the stack should be greater than the value that we just encountered, which you will see will be happening in this part of the array. So let's kind of redraw everything, and we'll start from scratch for the strictly decreasing array now. We'll see how the answer comes 4. Alright, let me redraw everything and then we'll start from scratch. Alright, so now since we are done with the length of this finding the strictly increasing array, now we have to do the same thing, but we need to find the length of the strictly decreasing array. So far our first iteration is done, in which we found the length of the strictly increasing array, and it was 5. Now we need to do the same operation, but in this case we'll be finding the length of the strictly decreasing array, which is 4 right here. So you'll see that the logic remains the same, just few things are getting tweaked here and there. We'll see how. So initially our stack will be empty. For this case as well, stack will be empty, and the length that we are starting with will be 0 is what we're going to start with. The first element that we encounter is 1 and our stack is empty, so we append 1 to this stack and update our length from 0 to 1, and then do the comparison of the max length and the length that we currently have. It's still gonna be 5. Then we move to the second element, which is 2, and we found that the element that we just pushed in the stack and the element that we are currently at, the element that we just pushed in the stack is less than what we are currently at, so meaning we are at an increasing trend. We don't want that. So whenever that happens, we'll have to again put the stack to an empty and set our length, put the stack to empty, append whatever value we just at, which is 2, and then again update the max length to 1, like not the max length but the length that we are currently working at, to 1, in hopes that we'll find a decreasing array further down the line. And then I do the same comparison, it's still gonna be 5. Then we reach 3. You see, just like how we were doing in this case, where after 5, when we encountered a lesser value, we emptied the stack. In this case, whenever we'll be finding an increasing value, we'll empty the stack. That's the opposite thing which is happening. So again, we find a 3 which is greater than the value that we just pushed in the stack. The same thing is going to happen. We're going to empty the stack, push the value 3 in it, and set the length that we are currently working at back to 1. So this is a kind of, you could say, a new start. Every time we find a greater value, we are doing a new start basically. So far the length was 1, we found a greater value, we are doing a new start with the length 1 back again. Again a greater value we are doing a new start, in hopes that we find a values decreasing from here on. But that's not the case up till 5. So this will keep happening for all these values up till 5. 4 also will be the same thing. We find that we reached at 4, the value that we just pushed in is less than value 4. So again we are at an increasing trend. Empty the stack, push 4 in it, and set the length that we are currently working with to 1. Same thing with 5. We will empty the stack, set 5 to the stack, and then set the length to 1, in the hopes that from 5 onwards we'll at least find lesser values, which we are gonna kind of see, right? We're gonna see in this case. So 5 is what we are starting with, and then comes 4. We found that the value that we are currently at, which is 4 right here, is less than the value that we are at the stack. So what we'll do is we'll update this stack and push 4 into it, and then update the length that we are currently working with a plus 1. So now this 1 becomes a 2. Now we'll do the comparison. Since 1 got changed, now we'll do the comparison with 2 and 5. 5 is still the greatest, it's still the 5. Now comes 3. The value that we currently at, which is 3, is less than the value that we just pushed in the stack, which is 4. So again we'll do 5, 4, 3. 3 gets pushed in the stack, and the length gets increased from 2 to 1, which is 3 now. We did the comparison, 5 is still the greatest. Then comes 2. We push 2 to the stack. Why? Because 2 is less than the value that we just pushed in. We are not a decreasing streak. So we push 2 now, 5, 4, 3, 2. Update the length that we have so far to a plus 1. This length gets increased by 1, which is 4. Do the comparison again, 5 is still the greatest. Now we come to 1. We saw 1 is less than the value that we just pushed into the stack, which is 2. So we'll again push 1 now, because we are on a decreasing trend. So 5, 4, 3, 2, 1. Update this value to 5. Do the comparison, 5 is still the greatest. So in this case, the answer is 5 for a strictly decreasing array, which is exactly this one. Started from 5, you see, we started from 5, kept on adding values in the stack because we kept on encountering lesser values. If at any moment we would have encountered a value which was greater than the previous value that we just pushed in the stack, we'll preserve whatever length that we have so far, and then again update our stack to empty, push that element at which our streak broke, and kind of hope that we'll find increasing or decreasing values, whatever it is, further down the line. So this is how the algorithm is working. Now let's try to code this up. So as we said, we will be needing a max len, and initially let this max len be, you could say, equal to 1, or you could say let it be 0, and our will be 2 lengths that we'll be working with, which is length 1 for finding the length of let's put max len just as 1 as of now, because we saw in the case of 3, where the values are just the same. If you see, like one small test cases, let's discuss this one final test case where values are all same. If the values are all same, none of our conditions that we just talked about will be satisfying. Values will be neither increasing nor decreasing, so nothing's gonna happen. Every time we'll do, what will happen is we'll be initializing an empty stack. We are at this, our stack is looking like this. The next value comes, It's neither increasing nor is decreasing. So what we will be left with? Nothing exactly. So we'll still do this, we'll keep on doing the same thing. So in this case our max length will still remain 1. So let us start with the default value of max length as 1 for cases where all the values are same. Where cases where all the values are same, let's put the max length as 1 for that case. So that is why what we'll do is we'll start the max length as 1 and len 1 will be 0 for the, in the case where we are finding the length of the strictly increasing, and len 2 is in the case we are finding the length of the strictly decreasing. This is what we're going to start with, length 1 and length 2, and then we'll also need a stack, right? Now the case of finding strictly increasing. Now we're going to do the strictly increasing operation now, which is the first one. So we start iterating the values. So for values, each value that we encounter in nums, so there are two cases, either the stack is going to be non-empty or the stack is going to be empty. If the stack is empty, in that case we have no other option but to append the value in 1, append this value in stack and set our length 1 to 1, which is in the first case. When we encounter the first number, our stack will be initially empty. So if the stack is there, we'll see this later, but if the stack is empty, what we'll have to do is we'll have to append the value which we just encountered to this stack and set the length to 1, then 1 to 1. Now if you see, this is also the case wherein our streak will break. What I mean by that is, let's say that now our stack is non-empty for the next value which we will be encountering. The next value, the stack will be non-empty. Now if that next value is strictly increasing, like we saw in this case, like 1, 2, 3, 4, 5, we see that we start with 1. So this is our kind of the second condition. We started with 1, we put the value 1 to the stack. Now stack looks something like this, and our length 1 is updated from 0 to 1. This is our starting case. The next value could either be greater than or less than. If it's equal to, then we know how it's gonna happen. But if it's greater than, then what we need to do is we need to add that value back to the stack, update this to 1. But if it's less than that, what we discussed, if it's less, then we know that we'll have to again empty the stack, push that value wherever we found that lesser value back to the stack, and then again update the length to 1. So you could say that we are kind of dealing with both the cases, which is encountering the first element, and the operation that we want to do whenever we find a value which is less than that are kind of same. Meaning you will have to first, what we do is set the stack to empty, append the value that we just encountered which broke the streak to the stack, and update the length to 1. So this is the case where the stack is when we encounter the first element, or when we encounter a value which is lesser than, or kind of where our streak broke, where that increasing streak broke. And if that's not the case, if we have values in the stack and the value that we just pushed in the stack, right, is less than the value that we currently at, in that case you'll have to append this new value in the stack, update this length 1 with a +1, and do this max, kind of update this max value with the length that we just found, right? So in the end, when after this loop completely terminates, we'll have the length of the strictly increasing. Now we need to do the same operation on the strictly decreasing, but then again we'll have to empty the stack now to start fresh. So let's empty the stack, and then we're going to do the same operation, and again everything will remain same, only this greater sign is going to from this less than sign is going to turn to a greater than sign. So we'll see that everything will remain same, only this less than value that we have here will turn to a greater than value, meaning if the value that we just pushed in will be greater than the value that we just encountered. In that case we're going to update length 2 now, because length 2 will be the length of the strictly decreasing array. Everything will remain same, and so let's do that. So if stack is there, if like we have values in the stack and the value that we just pushed in the stack, which is stack -1, is greater than the value that we just encountered, in that case we'll have to append this value first to the stack for the further iteration, and update our length 2 with a +1, and update our max length. We'll see if the max length changed, if in any way, comma length 2. So we have this, and if that's not the case, meaning the streak broke, or if we are at the first value, stack will be empty, append that value to stack and set length 2 back to 1 for further iteration, like further down the line if we ever encounter a value which is even lesser than that. So this is why we are updating length 2 to 1. Everything will remain same, only this less than will turn to a greater than. And in the end, we just have to return max length. Let's try to run the test cases. So you can see it's passing all the test cases, even for the case where all the values are same. If all the values are same, right, every time we run the values, it's gonna go in the else condition. Every time will go in the else condition. So in that case, our length 2 will eventually be set to 1 every time. But we are not updating the max length here. That is why we are updating the max length 1 right here. So that when the values are all same, there's no need to do anything else, just return max length, which will be 1. Because if the values are all same, every time it's gonna execute the else condition, because it's either checking for a less value or a greater value. Since values are all same, so this if condition will never get executed, will always go in the else condition. Values are same. Every time we'll be emptying the stack, put that value to the stack, and then update the length 1 to 1. This is what will be happening. So that is why it's better to just return max length eventually. So this is how the algorithm is working. It's a pretty standard stack question. So let's try to submit this now. So you can see it's passing, it's beating 60% of the solutions, and it's a linear time complexity as well, because we are just iterating the length, iterating the nums array that they provided 2 times. One for finding the length of the strictly increasing, and the other time for finding the length of the strictly decreasing. Whichever way, in whichever side we get the maximum length, we just return that. So that was it for today, everyone. I'll see you in the next one. Like and subscribe. Bye.